Hello everyone, welcome back to Clear Creek Solutions instructional videos. Today it's another FE exam review problem on hydrology and water resources practice, and today is a conceptual question. And a lot of the times we will overlook the conceptual problems on the FE exam, but there's quite a few of them. Anywhere from 10 to 15, sometimes 20 conceptual questions that don't require calculations, don't require the time-consuming number crunching, but are more about the thought process and your understanding of the material. And so it's good to test yourself on these questions as opposed to learning how to find an equation and bang it out on the calculator. Sometimes you got to think about things and sometimes think from a more meta test perspective when you think about these conceptual questions. So I'm your instructor. And quickly about Clear Creek Solutions, we do software development, hydrology education, and clinics such as this FE exam education, as well as stormwater analysis and facility modeling for stormwater projects. But anyways, let's get into the problem. So here's the problem. Flow with a Froude number of 1.2 can be accurately defined as. So we've got the four answers: subcritical, critical, dispersed, and supercritical flow. Those are the four choices here. Now, your gut instinct might be, okay, I got to find the problem and I got to punch something in on my calculator. But let's take a step back for a second here. Let's think about, what do these flows mean? Let's find the equation. Let's find some definitions, and let's think about what we're looking at here. So we know we're given the Froude number of 1.2. We know we have that. We know we need to classify it. And if we go to this section in the FE manual where it says Froude number equals a ratio of inertial forces to gravity forces, you're like, wow, this is a lot to take in. What does this mean? Well, we know here that supercritical flow is defined as a Froude number greater than 1. So we have the answer. There was no calculations involved. Sometimes it just requires searching the FE manual for the correct thing. I want to talk a little bit about the Froude number though, because there are some problems involving dimensional analysis on the FE exam. And what is dimensional analysis? Well, dimensional analysis is where we take a certain design at a certain aspect ratio. Let's say you had something that had a length of 2 feet and a depth of 3 feet. Then we take it and we, let's say you want to find the flow over an object that had, a length of 2 feet, a depth of 3 feet. And then the real design, it had a length of 5 feet, had a length of 5 feet and depth of 15 feet. Well, would the flow be the same if we increase the ratio like that? Not necessarily. So we have to use these dimensionless numbers such as the Froude number, and there's plenty of other numbers in the FE exam, but one of the most common ones is the Froude number. And we have to use these ratios to find how the values in the real world would actually increase, because when dimensions increase like that, it doesn't always 100% translate to the same result, or exactly 5 times of what we had before. Leave a comment if you want me to talk more about dimensional analysis here. But by looking at this definition, we do know that supercritical flow is the Froude number greater than 1. So that was pretty easy from a problem perspective. We didn't freak out. We just went, okay, what do I know about the Froude number? Let me look that up. And the answer was right there in the FE manual. So it is D, supercritical flow will be the answer to this problem. If you're struggling with your FE studying and you want a little bit of a guide, especially when it comes to water resources engineering, which can be the most challenging, I have a free guide in the description box. Just click the link down below, download that guide for free, and hopefully it'll help you pass the FE exam and get better. We're Clear Creek Solutions, and we thank you for watching this video.